Hello viewers, welcome to Unacademy YouTube channel. Myself Vetrivel, Unacademy plus physics educator. Welcome you all for today's session, Elasticity or mechanical properties of solid. Unacademy, it is the #1 online platform on teaching and coaching. So Unacademy Plus course is going on. It is the best opportunity for all the aspirants, those who are preparing for KCET, NEET and JEE. Complete syllabus coverage will be taken care and the topmost lecturers on this platform. So you can detailed explanation, doubt clearing session, live interaction, everything will be available. So it is affordable price. Have a trial at least for a month. You can able to see that all the live classes PCMB. Use my code Vetrivel Live to get additional 10% discount. So once again, I welcome all the viewers for today's session, Elasticity. Right? Welcome all. Elasticity, mechanical properties of solid. We know that mainly here Hooke's law. Remember, within the elastic limit, stress is directly proportional to strain. Stress by strain, the ratio is constant. Young modulus, we know that there is 3 modulus of elasticity. We all know the basic elastic plastic. So 3 modulus of elasticity, the main formula you must know, Young modulus, normal stress by longitudinal strain, or simply Young modulus equal stress by strain. Right, we know that stress is force by area and strain change in length by original length. Strain is a pure ratio, it has no unit, no dimension. So Young modulus, stress by strain, F by A, stress, strain is change in length by original length. Bulk modulus, normal stress by volumetric strain, see there, normal stress, F by A, volumetric strain, change in volume by original volume. This force by area is nothing but pressure. That's only change in pressure, force by area. So pressure, this V will come up. So minus V into, right, change in volume. See here, the negative sign shows, right, volume goes on, decreases. Now, shear modulus, tangential stress by tangential strain. This is F by A theta. Theta is nothing but delta L by L, change in length by original length. These formulae, Young modulus, bulk modulus, keep in mind, very useful for all the competitive examination. We know that breaking strain, remember, the maximum stress in the sense force acting per unit area, the maximum stress that can be applied to a material without fracture, without breaking, that's only called breaking stress. It is also called ultimate tensile strength. So the breaking stress is breaking force by area of cross section. Breaking stress is independent of length of the body. Just have an idea of this. We know that K, it is small k, is compressibility. Compressibility is the reciprocal of bulk modulus, where here capital K is bulk modulus. We just now discussed bulk modulus, right? So reciprocal of bulk modulus is called compressibility. Now, elastic potential energy stored per unit volume in a strained body. right? Elastic potential energy. Suppose a spring, when we apply the force, right, the work done to elongate the spring is stored in the form of potential energy. That's only elastic potential energy stored per unit volume is half into stress into strain. Here half into stress into strain. Strain we can write, we know Young modulus equal stress by strain. Right, from this strain take it up. Strain equal stress by Young modulus. Why bring it down? In strain place substitute stress by Y Young modulus. Then you will get stress into stress square by 2y. So keep this in formulae, or if you place in place of stress you can keep strain into y. You will get strain square y by 2. Anyway, use this Young modulus formula. Substitute, you will get this elastic potential energy stored per unit volume. Work done in stretching a wire. So the work done in stretching the wire is stored in the form of elastic potential energy. That's only we have seen. 1 by 2 half into stress into strain into volume. Just now see here, elastic potential energy stored per unit volume. That is only work done. The work done in stretching a wire is stored in the form of elastic potential energy. So work done equal half into stress into strain into volume. Stress half, stress we know, force by area. Strain, increase in length by original length. Volume, area into length. All substitute, right? L cancel here, A also cancel. You will get half into L into elongation or increase in length. Half into F is load, right? L is extension or increase in length. This is work done by stretching a wire, right? Yes. Let us now, you have this important formulae in elasticity. Now let us move to some important basic problem which are very useful for all the competitive examination. Yes, let us go for the first sum. If S is stress, given clearly, letter S denotes stress. Y is Young modulus, right? Y is Young modulus of the material of the wire. Then the energy stored in the wire per unit volume is, just now we discussed, right? The energy stored in a wire per unit volume is, we know that energy stored, right? The energy stored in a wire, the energy stored in a wire per unit volume equal, we have the formula, the energy stored in a wire per unit volume equal half into stress into strain, half into stress into strain, right? That's the formula we know. Now the same you substitute now, the energy stored, U equal half into, right, stress into strain. We know Young modulus equal to stress by strain, right? So from this, strain equal stress by Young modulus, right? That substitute now. In the strain place, substitute stress by Young modulus. Stress by Young modulus. We know that stress is denoted by S. So half into S into stress is S by Y, Young modulus. That's it. So you will get S square by 2y, the energy stored per unit volume. So we know option 1 is absolutely correct. Let us go for next one. Here it is. A stretched rubber has increased kinetic energy, increased potential energy, decreased kinetic energy, decreased potential energy. Right? See the option and then question properly. When rubber stretched, the work done to do so is stored in the form of elastic potential energy. See, whenever a rubber is stretched, whatever we do the work done is stored in the form of elastic potential energy. So what happens? The potential energy increases, right? So a stretched rubber gas, option B, right? Increased potential energy, because when the rubber stretched, the work done to do so is stored in the form of elastic potential energy in the rubber. So the potential energy increases when the rubber is stretched. Next one. What percent length of a wire will increase by applying a stress of 9.8 Newton per millimeter square on it? Young modulus is given. Young modulus of the wire is given. What percentage of length of a wire will increase? How much percentage of length of the wire will increase if we apply the stress this much on a wire? Young modulus is given. We know Young modulus equals stress by strain. But when we apply 9.8 Newton per millimeter square stress on a wire, how much percentage of length will increase? Right? Question, I hope you are clear. Now, we know that, right, strain is change in length by original length. We know, right? This strain we can write, right? Strain we can write stress by Young modulus, right? Because we know Young modulus equal to stress by strain. Young modulus stress by strain. From this stress equal, see, strain equal stress by Young modulus. So strain I can write Young modulus stress by strain. So strain equals stress by Young modulus. Yes, equal, what is stress is given here? See that 9.8, but see that Newton per millimeter square. Per millimeter square. Millimeter square, how can you convert into meter square? Millimeter into meter divide by 1000, right? But when we have to convert millimeter square into meter square, 10 power 6, that means 10 power minus 6, that you bring it up, you will get 10 power 6. Now Newton per meter square. SI unit I changed. Newton already SI unit. By Young modulus is given here. 1 into 10 power 11 Newton per meter square. That's all. Now value all is given. Divide now. This is equal to 9.8 by 1. 9.8 into 10 power 11, bring it up. 6 minus 11, you will get 10 power minus 5. Now 9.8 divide by 10 power 5. So this is strain, you got it. Question is, what percentage of length of the wire increases? That is why we choose the strain, because strain only change in length by original length. Now we need to calculate percentage increase in length of the wire. So percentage increase in length. percentage increase in length equal increase in length by original length into 100%. Increase in length by original length into 100%. Formula always keep in mind. Percentage increase in length, change in length by original length into 100%, right? 100 percentage. So we know that already strain, change in length by original length is stress by Young modulus, we got it. So 9.8 into 10 power minus 5 into 100, right? You will get 0.0098%. Right, option C is the correct answer. The percentage increase in length. So stress Young modulus given, first to find strain. So strain if you get, then we know increase in length is percentage increase in length, change in length by original length into 100. That's it. You will get option C. Yes. Let us go for the next question. Right? Here it is. Unacademy Plus. Right? If you subscribe Unacademy, it's a non-stop 24/7. You can able to see many live classes and recorded videos, whichever topic you need, everything on a single subscription. Right? It is the best plan and the best option for all the aspirants, those who are preparing for KCET, NEET, JEE. So use my code Vetrivel Live. It is available in description box. Use my code Vetrivel Live to subscribe Unacademy and enjoy the learning. We'll move to next question. According to Hooke's law of elasticity, we all know Hooke's law, stress by strain within the elastic limit, the ratio of stress by strain equal constant. That's it. Now you see, according to Hooke's law of elasticity, if the stress is increased, the ratio of stress to strain, right? If the stress is increased, the ratio of stress to strain, we know Hooke's law, within the elastic limit, stress is directly proportional to strain. According to Hooke's law, within the elastic limit, the stress produced in a body is directly proportional to strain. So make equal now, stress is equal to some constant into strain. Then strain, bring it down. Stress by strain is equal to constant. So it remains constant. Even if you increase the stress, the ratio of stress to strain is remain constant. Option 4 is the correct answer. Yes, let us go for the next one. The reciprocal of bulk modulus of elasticity is called. We know bulk modulus is nothing but capital B. The reciprocal of bulk modulus 1 by B is equal to compressibility. Keep in mind, right? The reciprocal of bulk modulus is compressibility. So option A is absolutely correct. The reciprocal of bulk modulus of elasticity is called compressibility. Yes, let us go for the next question. Here it is. Which one of the following quantities does not have the unit of force per unit area? Right? Which one of the following quantities does not have? That's only the key point. Always theoretical question, while reading question itself, the lateral thinking, you need to see the key point, right? Which of the following quantities does not have the unit of force per unit area? Right? We know force per unit area. Force by area is nothing but stress. Right? Pressure also force by area only. Pressure also force acting per unit area. Stress is nothing but force by area. Right? Young modulus is nothing but stress by, right? Strain is no unit. So strain, since no unit, stress is force by area. So pressure, Young modulus, stress all have the unit of force per unit area. And which quantity does not have? Strain. So keep in mind, strain is the ratio of change in length by original length. That is why strain is a dimensionless. We all know strain is a dimensionless quantity and even unitless. There is no unit. So strain is dimensionless and unitless quantity which does not have the unit of force per unit area. Remaining all is force per unit area. So correct option B. Strain is the correct option which does not have the unit of force acting per unit area. Let us go for the next question. The length of the wire increased by 1% on suspending 2 kg weight from it. The linear strain in the wire is. Question, try to understand. The length of the wire increased by 1% on suspending 2 kg weight from it. Right? So, the length of the wire, when we suspend 2 kg weight, the length of the wire increases by 1%. Then linear strain produced in the wire. We know that strain is, right, change in length by original length. We know. What is that ratio given? See, the length of the wire increases by, that means increase in length by original length. So this is given already, 1%. The length of the wire increases. So strain is increase in length by original length. That's only change in length by original length. It is given, right, 1%. Right? So 1% in the sense we know 1 by 100. 1 by 100 how much? 0.01. So what is the linear strain? Linear strain will be 0, option A, 0.01. Right, that's it. So very simple. Analyze the question. Easily you can. We'll go for the next question. Here it is. The dimension of 4 wires, right? The dimensions of 4 wires of same material are given below. In which wire the increase in length will be maximum when the same tension is applied? Tensional force. Tension is nothing but force, right? When same tension force applying, 4 wire, all are made same material, right? In which wire increase in length will be maximum? Keep in mind, in which wire increase in length will be maximum? See that all the 4 wire length is given, diameter is given. Out of these 4 wire, length, diameter is given. Which wire will be, the increase in length will be more when same tensional forces act on it? Right? So, see that we know Young modulus, right? Young modulus is stress by strain. Stress is force acting per unit area. By strain, strain we know increase in length by original length. That we can write F, this L will come up, FL by A into delta L. Right. Here you can see that this L is proportional to delta L by A. Correct? See that. So this relation, see, we know Young modulus stress by strain. Stress F by A. Strain we know delta L by L. Now FL by A into delta L. How the L is related to A and delta L? L is, see that, proportional to delta L and A. Now this is proportional to change in length delta L by what is area? Pi d square. Here diameter is given. So area, right, instead of pi r square, wire shape we know. Instead of pi r square, here diameter given, so pi d square. Therefore, very simple. This length, increase in length, in which wire increase in length will be maximum. See here, the length L is, right, proportional to increase in length by pi d square. That meaning pi leave it. This L is proportional to, right, length by, what is that, d square. Even if you want to change in length, length into d square. Now see that this actually not necessary. You can keep this relation, right? So this is length is proportional to, directly proportional to length and inversely proportional to d square. But both cases you can see that L by d square is maximum, in which case you see length and diameter. Maximum in which case you see here. L is proportional to, directly proportional. That means if it increases, this also increases. Out of the four options, in which option L, length and diameter is maximum you see? Fourth option, length 50, right, centimeter and diameter is 0.5. So option D is correct. See that is proportional to change in length by d square. Option D is correct one. L by d square value you substitute here, man. Take it L, delta L 100 by d square, diameter do, you will get value. Second wire take it, delta L by d square, L is here 200, d square 4, do that, you will get value. Similarly third take it, L by d square, you will get. Similarly do that. All this L by d square value you will get maximum for fourth option. So increase in length will be maximum, right, for fourth option is the correct one. Let us go for next one. On applying stress is given Newton per meter square, the length of the perfectly elastic wire is doubled. The Young modulus will be, we know Young modulus is, right, stress by strain we know, right, as length of the wire get doubled. See that keyword, this is important keyword you need to analyze. As the length of the wire is doubled, therefore strain will be 1. Strain is change in length by original length. Length of the wire doubled mean what happened? Strain become 1. Now strain 1 mean what happened? Young modulus is equal to, right, stress. That's it. So strain is 1. So Y equal to stress. What value is given stress? 20 into 10 power 8 Newton per square meter. So option B, same as it is. On applying stress this much, the length of the perfectly elastic wire doubled. So as the length of the wire get doubled, therefore strain is same. Change in length, original length twice. So cancel 1. So strain is 1 mean Young modulus equal to stress. That's it, same value. Don't get confused. Next problem. Which of the following substances has highest elasticity? See that. Which of the following has highest elasticity? Which substance has greater Young modulus? Keep in mind. Greater Young modulus, right? Steel has greater Young modulus among the following. Greater the value of Young modulus of a substance, higher is the elasticity. Which of the following substances, out of these 4 following substances, Young modulus value is more for steel? So which substances has greater Young modulus will have greater elasticity? So option B is correct. Let us go for next one. Young modulus of perfectly rigid body material is. Young modulus of perfectly rigid body material is infinity. Since it is a perfectly rigid body, Young modulus, right? It will be infinite. Perfectly rigid body material, Young modulus value will be infinity, right? And come to the last question. A uniform cube is subjected to volume compression, right? So if each side is decreased by 1%, then what is bulk strain? Keep in mind, a uniform cube. What is the cube side? If you take cube side is L, suppose you take it. If the side of the cube, right? If you take the side of the cube be L, now what is the volume of the cube then? Volume equal to side cube, L cube, right? Now V equal to L cube, right? So V equal to L cube. Now see that what is the change in volume? Yes. Now volume equal cube is given. So L cube. Here this one, see that change in volume by original, right, equal L cube. 3 will come first into change in length by original length. That's it. Right. Now percentage in change in volume. Percentage change in volume will be, right, percentage change in volume equal, how much is given? Percentage change in volume here, see, percentage change in volume is 3% of, right, 3 into change in length by original length. That means 3 times percentage change in length, right? That's only we got it. Now see that V equal to L cube. So dV by V, percentage change in volume equal thrice change in length by original length. So change in volume, question C, if each side is decreased by 1%, then what is the bulk strain? So change in volume equal 3 into each side, length is decreased by 1%. So 3 into 1%, 3%. This is change in volume. Now what is the bulk strain? Right? Now the bulk strain equal, right, bulk strain is nothing but change in V by original V, right? Bulk strain, change in volume by original volume, that is equal, percentage how much is given, right? 3%, right? 3 by 100, that's it. So 0.03, option D. Okay, then bulk strain will be 0.03. Option D is the correct answer. Right? That's the end of today's session. I hope you learned, right, some of the important concept in elasticity, mechanical properties of solid. So this is a simple model. Similarly, if you subscribe Unacademy Plus course, using my code Vetrivel Live, you will get many more, right? The important problem and shortcut tricks and tips, everything will be very useful for your preparation of all the competitive examination. So with this, myself Vetrivel, Unacademy plus physics educator, signing up from you all. Have a nice day. We'll see you in the next YouTube session with another important concept. Till then, bye.